All right, good afternoon. All right, well, let's start with the roll here. All right, Jimmy,
He's not here.
Joanna,
Here.
Ashley,
Here.
Marissa, Caroline,
Here.
Courtney, Jada,
Here.
Autumn,
Here.
Matthew,
Here.
Weston,
Here.
Chan,
Here.
Kelly,
Here.
Porter, Trey, Kayla,
She's not here.
thank you, Tobias, Nathan,
Here.
Rebecca, all right, well, so we do have a little situation in that Mogion, their system is out. But since we have more than half the students here, then I'm going to go ahead and teach, and hopefully they can just watch the video later. I do kind of have a policy, my own policy, which is that if ever I have less than 50% of my students, then I don't have class. So anyway, just to let you know that. But so today we're going to continue on 3.1 that we started that last time. And also well, anyway, as I'm loading that up, does anyone have any questions, comments, concerns? Okay, whoops. All right, so okay, well, let's go ahead. I think we were on this first practice problem, and I had asked you to work on this one. Seems like we went over part A, is that correct? Did we go over the answer to part A? That was -5. You do the f of x, the limit as h approaches 0 of the f of x plus h minus the f of x all over h. And then you do that algebra trick where you take 5 times x minus 2 minus 5 times x plus h minus 2 all over x plus h minus 2 times x minus 2 times h. Maybe that's as far. I remember going that. I don't know. Did we finish this first part? Or is that all we got to?
That's all we got to.
That's all we got to. All right. So then if we distribute the 5s, okay, then, and just leave the denominator alone. Then what happens is your 5x's cancel, your 10's cancel, and so all you have is negative 5h. Now, you know when you're doing these problems right, when the h is set up to cancel. And see, now you can cancel the h's. And see, the reason why that's so important is because beforehand, if you try to plug in 0 for h, you'll end up with 0 over 0. But now, once you cancel the h's, now you can plug in 0 for h again, and you won't get 0 over 0. What you'll get is negative 5 over x minus 2 times x minus 2. So you get negative 5 over x minus 2 times x plus 0 minus 2, or negative 5 over x minus 2 squared. Okay? All right, so any questions on the first part? Okay, so then the next part was, what is the slope at x equals 1? Okay, so let's call on Weston. So what's that slope at x equals 1?
Would it be negative 5?
I think so.
Oh, Mr. Strong,
Uh-huh.
James just came in.
Oh, okay. Thanks, hey, Jim. So yeah, it's negative 5. Okay. So you plug in negative 1 into the derivative, and then you work it out. So you get negative 5. Good. All right, let's see, what was the last part? Where does the slope equal negative 5/4? Okay. So let's see if you can remember that, how to do that. So where does the slope equal negative 5/4? So let's go with, we'll give Jimmy a break. He just walked in. Okay. All right, Nathan. Where would the slope be equal to negative 5/4?
At 4 and negative 2.
At 4, negative 2. Yep. Well, oh wait, no, at 4 or 0. See, when you plug in 0, you'll get negative 2 squared is 4 in the denominator. See, they have the same numerator. So when you set the slope equal to negative 5/4, so you just have to make the denominator equal to 4. And so when this is equal to, when x is 0 or 4, when you square it, you get 4. Does that make sense?
Yes.
Okay. All right, very good. Any questions on any part of that? Anybody need me to go through any of it again? Okay. Well, did anybody do anything amazing over the weekend?
We had homecoming. So that's always fun.
How'd you do?
What?
Hey, we did great.
Good.
We won. For sure.
Yeah.
Yes. We won the football game, and then the actual homecoming was fun too.
It was a win.
Oh, good. Well, that's what it's all about. I mean, it's weird because, I teach the first 2 periods at Holbrook, and they had their homecoming. I think all week it might have been one of the most fun homecoming weeks I've been associated with, but I think they lost the football game by like 50-something points, so that was not good. But anyway, they still had a good time, so that's all right. All right. So next it says to find the derivative at a particular point, you plug in for x at the beginning or the end. Okay? So you can, when you're doing the f of x plus h minus the f of x over h, you can plug in then, or you can wait and do the derivative in terms of x and then plug in at the end. Okay? Now, what I would recommend is if you just need to find the slope at the point and you don't need to find it in general, then I would say plug it in at the beginning. It makes the calculations a little easier. But if the question says find the slope first, then plug it in at the end. Okay? So here's an example where I'm going to plug it in at the beginning. Okay, because we really haven't done that much. So let's say I have f of x equals the square root of x, and I want to find the f prime at 4. So that means I need to find the derivative and then plug in 4. Or I could plug in 4 and take the derivative. That's what this example is all about, is that you could plug in the 4 at the beginning or the end. Okay? So I'm going to plug it in at the beginning. So then at the f of 4, so that would be square root of 4 is 2. And then if I plug in 4 here for x, then I get the square root of 4 plus h. Okay? Everybody with me so far? Okay. All right. So now we'll do our limit. So the f prime of 4 will be the limit as h approaches 0 of the f of 4 plus h minus the f of 4 all over h. Okay, now I still can't plug in 0 here, because if I do, I'll get 0 over 0. Now, this time I can't factor anything out, nothing cancels. So does anyone remember on the ones where I have a radical, how do I take care of that? What do I do next?
Would you multiply the numerator and the denominator with the square root of 4 plus h plus 2?
Yes, the conjugate. Good, very good. Okay. So we haven't done that technique since the early part of chapter 2. So we have the radical of 4 plus h plus 2 is what we're going to multiply by. And really don't even multiply out the denominator. You're just going to, it's the numerator. Because when you're multiplying a conjugate, you're going to get the 4 plus h is going to come out of the radical minus 2 times 2 is 4. Because the outer and the inner products are going to cancel. So now the 4's will also cancel. And so then your h's are going to cancel. And see that, it tells you you're doing the right thing. When you get the h's to cancel. Okay? So now you're going to have 1 over the radical 4 plus h plus 2. And now you can go ahead and plug in the 0. Because, again, once you cancel those h's, you're not going to get 0 over 0 anymore. So you cancel, and so you're going to get, you plug in 0 for h, and so you're going to get 1 over the square root of 4 plus 2, 1 over 2 plus 2, or 1/4 is your answer. So that's the derivative at that point. Okay? All right, any questions? Now, when we're taking the derivative using the limit, what we're doing, it's called using the definition of the derivative. Okay, is that limit? There's other shortcuts that we're going to learn later, but what we're doing is using the definition of the derivative.
Don't you, when you take the square root, you get a positive and negative answer? Do we just do the positive?
Well, it's not like we were solving where we took the square root of both sides, because in that case you're absolutely right. But in this, the function is just the square root of x. So we're not taking the square root of both sides of an equation here. Okay, so we don't have to worry about plus or minus. Okay, so this says find the derivative of y equals the square root of x plus 2 at x equals 1. All right, so see if you can do this one. And you can plug in the 1 for x at the beginning or the end, whichever you prefer.
No.
All right, let's see, is Rebecca here? I don't think so. All right, Jada, when you've got it.
I don't know. I got lost.
Okay. So, did you try plugging in 1 at the beginning or at the end?
At the end.
Okay. All right. So, well, let's try it at the beginning. Okay. So here, if we plug in 1 at the beginning, then the f of y equals the square root of 1 plus 2 would just be 3. Okay. And so then we have the limit as h approaches 0 of, so the f of x plus h, so 1 plus h, here let's, all right, hold up just a second here. Okay, so the f of x, if we plug in 1, is 3. Okay, then the f of 1 plus h, so that's just the square root of 1 plus h plus 2. Okay, so now when we do the limit, oh, there it is right there. Why did I not see that? Sorry. No, it's already up there. Okay, so we take the limit as h approaches 0 of the f of x plus h minus the f of x all over h. Okay, so then as we simplify this, 2 minus 3 is negative 1. So then what do we multiply this by to get it to come out of the radical? It's just like the example we did. What would we multiply by?
The conjugate.
The conjugate. That's right. Whoops. So we're going to multiply by okay, let's try this again. So radical 1 plus h plus 1, both numerator and denominator. And so then when I multiply by the conjugate, then 1 plus h squared will come out of the radical, and then the outer and the inner terms cancel, and then I have minus 1. And then the denominator, don't multiply it out. So then the 1's cancel, the h's cancel, and so I'm left with 1 over radical 1 plus h plus 1. So now I can plug in 0 for h. So then that's going to give me 1 plus 0 under the radical, or the square root of 1, and 1 plus 1 is 2. So the answer is 1/2. All right, were you able to get all that, or do I need to scroll up a little bit?
Just scroll up.
Okay, sure. So I know I was going a little fast there when we started canceling stuff.
Could you go a little bit more up?
I'm sorry, what'd you say?
Could you go a little bit more up?
Go up here or go down?
I think it.
That good? That's good there? Okay.
Oh, we're done. Thank you.
You bet. Okay. All right. So there are many ways to denote the derivative of a function. So, like we've been writing it as f prime of x, or you might see it as y prime. So the little slashy thing, you say prime, call that a prime, or dy dx. So these three right here, these three right here are like the main ones. And then, but you also might see this where they'll do capital D of f of x, or df dx, or df of x dx. Those are other ways, but I don't hardly ever use those, but you might see them in your book. But they all mean find the derivative. So f prime of x, y prime, dy dx, those are the ones that I use.
We have that dy over dx on our calculator. What is that useful?
That's that's very useful. What that is that as we get into some of the shortcuts, there's certain times where the calculator can help you find the derivative, okay? But for the ones that we're doing right now, not so much. But later, especially when we get into application problems, that you'll find that key will become your best friend, okay? So, good. All right, we can often make a reasonable plot of the derivative by estimating the rate of change. So we're actually going to learn how to graph a derivative just given the function, okay? So that's what we're looking at here. And so if you think about...
Oh, wait.
Is this in the guided notes?
One? Is this like a new section?
Oh, is that the end of it?
We have.
Okay, all right, hold on. Let me take a peek. Yes, okay, let's see where we are. Thanks, you guys, for keeping me honest here. Oh, that's in my orders. Oh, that's it. That's it for 3-1. Okay. What they did is they, in the previous edition, they they split the first section into two. So I'll put my little heart there. That tells me we're done with this section here. Okay. All right. So now we're going to go on to 3-2. Maybe. Okay, so the next section is called the derivative as a function. Okay. So the process of calculating a derivative is called differentiation. Okay. So the derivative, this is the definition of the derivative. So it's the same thing that we've been working on. Okay. So when I say use the definition of the derivative, this is what we're doing, is that same limit. The limit as h approaches 0 of f of x plus h minus the f of x over h. It's kind of like the slope, the difference in the y's, and then h is the difference in the x's. Okay? And so basically what I'm hoping is that by now you have these memorized, and this is memorized. You have no problem doing this. And so basically what we're going to start, well, really in the next section is I'm going to give you some shortcuts, but we're going to still do the definition for right now. Okay. All right. So remember the idea of the derivative, again, we take the secant slope is just any 2 points, but then as we take the limit as the difference in the x's approach 0, then we get the slope of the tangent. Now, the secant slope, they use the f of z minus the f of x over z minus x. And so there is an alternate form of the definition of the derivative. Let's see if I, okay. Well, I guess we'll get to the alternate form in just a minute here. All right, so here we did one like this in the last section. So it said, but we're using the word differentiate. So it just means find the derivative. But now this is one where we've got, let's just see if you can do it. Let's just see if you can do it, and then I'll reteach what I need to. Okay, so use the definition of the derivative to differentiate that function. So see if you can, and I'm not giving you an x value, so you can't plug in anything for x at the beginning or the end on this one. So you just have to do the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, so Chan, when you've got it.
Is it 1?
No. No, so let's go through it. So the f of x plus h. So you replace x with x plus h. So it's 1 over x plus h minus 1. So then you do the limit as h approaches 0 of the f of x plus h minus the f of x all over h. So it's 1 over x plus h minus 1 minus 1 over x minus 1 over h. Okay, now you do the algebra trick where I said you multiply 1 times x minus 1, which is x minus 1, minus x plus h minus 1 times 1, which is x plus h minus 1, all over x plus h minus 1 times x minus 1 times h. You can put the h in front or at the end, it doesn't matter. All right, so Chan, do you see how I got that, or do I need to explain it again? I mean, do you understand how I got this last step?
I'm just confused what it says below the limit.
Right here?
Yeah, right there.
You're confused about what, this step right here or the last step?
Does that say limit of h is approaching 0? Or is what this?
Yeah, that's the limit as h is approaching 0.
Oh, okay.
Yeah.
I didn't understand it.
Let me rewrite that. Okay. And so now when you distribute the negative on the top, you're going to get x minus 1 minus x minus h, and then minus a negative 1 becomes plus 1. And then the x's cancel, the 1's cancel, so all you have is negative h left on top. And so now this h here will cancel with this h here, leaving you with negative 1 on the top. Okay? So, but with the h's canceled, now you can plug in 0 for h. You won't get 0 over 0 anymore. And so you'll get negative 1 over x minus 1 times x minus 1, or x minus 1 squared. So that's the answer. Negative 1. Let's see. No, no. So negative 1 over h minus 1 squared. All right. So how's that, Chan? Do you understand the steps, or do I need to go through it again?
I get it now.
Okay. Now, how about this? Would you believe me if I said that by the end of chapter 3, you could do this whole thing in your head? You'll be able to do that problem in your head by the end of this chapter. Okay? And so you won't have to go through all of that. But it's important that you do it right now. I'm just telling you that you're not going to have to do this for very very long. Okay. All right. Any questions on this one? Okay. All right, so now this is the alternative formula for the derivative. I'm only showing you this because it's in the book and there's a couple of practice problems that you could do. I personally like just doing them all with the definition of the derivative. And so the only time I ever use this is when I'm teaching it to you. But I never take the derivative this way. But it's the limit as z approaches x of the f of z minus the f of x over z minus x. So it's kind of like, again, the points coming closer together. It's just a different way of writing it. Okay. So let me kind of, I'll do, So this is the same, is that on your paper, on this paper too?
Yes.
Okay. So I guess I really wanted to make sure you knew the different ways to denote the derivative. So again, it's these first three are the ones that we use the most. Okay. All right. So here we go. This is where we we're kind of starting the new section, really. We can often make a reasonable plot of the derivative by estimating the rate of change.
That's still not on our paper.
It's still not on your paper? Oh my God. Why this thing just wants to be somewhere. Oh well. Let's see. We don't need that.
It's not on any of the chapter 3 notes.
Okay. Okay, let's see, did I have you? All right, so let's just go to here. All right, so this was the alternate form of the derivative. Okay, so here I'm going to just show you how to use the alternate form. Okay, so it says, so what you do, so instead you calculate the f of x, or you're given that, and then the f of z, you just replace the x with z. So the f of z is the square root of z. Okay, and so then so for this one, it would be the limit as z approaches x of radical z minus radical x over z minus x. And so now you multiply by the conjugate again. Oh, no. Look, this actually has another algebra trick. Okay, so let me just make note of this. This is a new algebra trick. Okay. Can anybody see how we go from this to this down here? So we're not multiplying by the conjugate.
When you multiply the square root of z times the square root of z, you just get z, same as x. So you're just kind of pulling them apart.
Yeah, what it is it's like you're factoring the difference of two squares. But see, we're not used to doing that. We're not used to thinking that as the square root of z squared minus the square root of x squared. Well, let's put the squared on the outside just so it matches. See, we're not used to factoring a difference of squares like that, but that's actually the trick that they're doing here. Because so z minus x factors to radical z minus x times radical z plus x. Okay? So that's a crazy trick. Well, then you can cancel radical z minus x, and you're left with 1 over radical z plus radical x. And so then as z approaches x, you can plug in x for z, and then you get 1 over 2 radical x. Okay. So let's see what do we have here. Okay, so it says use the alternative formula to find the derivative of y equals radical x plus 2 at x equals 1. Okay, so I've kind of got it started here for you. And see if you can finish. If we don't, if the class ends, then I want you to finish this tonight. But we might be able to finish it really quick. Let's see how much time we have. We got a little time. We got 2 minutes, right? Oh, we got 1 minute. So if anybody gets done in the next 30 seconds, just call it out. Otherwise, we'll pick it up here tomorrow.